everyone. Today we are going to discuss Maths 9709 A-Levels paper of October-November 2024. It's paper 4-3 and we have discussed question 1 to question number 4, and today we will discuss the remaining questions of this mechanics paper 4-3 of 2024. Let's move to the question number 1. Question number 5 and question number 1 of today. And this one, first of all, we need to read the question. And in the question, they are saying that what we have to do is we need to understand and highlight the important points. Now, the very first thing they are saying that a particle of mass 12 kg is going to be pulled across a rough horizontal plane. Rough horizontal plane means that we cannot ignore the friction now. So by a light inextensible string, the string is at an angle of 30 degrees above the plane and has tension T newtons. The coefficient of friction between the particle and the plane is 0.5. It means the value of mu is 0.5. Given that the particle is on the point of moving, okay, it means that this thing is, the particle is about to move and it is not moving, so about to move, and the second about to move means that this is the case of limiting equilibrium. Limiting equilibrium. We know that when the particle is about to move, it means we have to use the case of limiting equilibrium, which means we cannot ignore the frictional force. Now, let's first of all identify the forces. We know that if the particle will move, or if the particle is about to move, then the particle will move towards the right side, which means that the frictional force will be towards the left side. So this side will be the direction of the friction, and we know that the weight will act downward. Weight will act downward, and the reactive force will be, the R will move, will be, the direction of the R will be upward. Now the next thing is we have to apply F is equals to MA. Now F is equals to MA means what? We have to add the forces. So we know that, let's find out the vertical forces and then let's find out the horizontal forces, because we need to find out the value of T. Now summation of Rx, summation of Ry, let's say the vertical forces. So summation of Ry will be, let's see all the vertical components. As R is going upward, so this will be equals to R, and then we have the vertical component of T. So the vertical component of T will be T sine of 30 degrees. So this should be plus because it is also going upward. So plus T sine of 30, and then we have the other vertical component towards the downward side. So this will be minus W. So we know that there is no acceleration, so we can write it as T plus R plus T sine of 30 minus mg. W is equals to mg. So m is 12 and g is 10 is equals to ma. Ma means this will be, mass is 12 and acceleration is 0 because the particle is not moving. Now if we rearrange it, so this will be, R will be equals to 120 minus T sine of 30. So this will be the equation 1. This will be equation 1. Now similarly, we have to see the other one, summation of Rx, the horizontal components. So for horizontal component, we know that the horizontal component of T is going towards the right side. is going towards the right side. So this should be T cos of 30 degrees minus frictional force. Okay, minus frictional force will be equals to, now we do not have any other vertical any other horizontal components, so we have to use these two. So this will be equals to ma means 12, acceleration is 0, so we can write it as T cos of 30 is equals to Fr, which means T cos of 30 is equals to mu r. This will be equation 2. Now the next thing we need to do is just put equation 1 in 2. So we will get T cos of 30 is equals to, the value of coefficient of friction or mu is 0.5. So we can use it over here. So 0.5 into r. R is 120 minus T sine of 30. Now if we simplify it, so we can use the calculator. 0.5 into 120, the answer will be 60. So we can write it as T cos of 30 is equals to 60 minus T sine of 30 into 0.5. So sine of 30 into 0.5. So this will be equals to 1 by 4. So 1 pi by 4 T. We can write it as pi by 4. So if we rearrange it further, it will be, let me find out, it will be T cos of 30 plus T by 4 is equals to 60. Now if we solve it, if we simplify it, we will get T will be, we can take T as common. So this will be cos of 30 plus 1 by 4 is equals to 60. And finally we will have T is equals to 60 divided by cos of 30 minus 1 by 4. So let's simplify it directly and then see what will happen. So cos of 30 plus 1 over 4, this will be equals to 1.116. Now 60 divided by the answer, 60 divided by the previous answer, this will be equals to 53.76. So T will be equals to 53.76. Let me write it over here. T is equals to 53.76. Now this will be the final answer. I hope that, okay, what will be the unit then? It should be Newton. So 53.76 Newton. So this should be the final answer. I hope that the concept is clear. If still you have any question, you can ask it in the comment section. Let's move to the part B. In part B, they are saying that given instead that the particle is accelerating at 0.2, find the value of t. Now we have to follow the same process. So what we can do is we can take the previous equations. So if we can use the previous equation, so here we can see that this one was the summation of Rx. Summation of Rx is equals to ma. Now we know that acceleration is now 0.2. So 0.2 we have to write it over here, and now we can easily simplify it and we can find out the value of t. So R will be equals to 12 into 0.2 plus 120 minus t sine of 30. Now from here we can see R is equals to 12 into 0.2. So 12 into 0.2 plus 120 plus 120, this will be equals to 122.4 minus t sine of 30. Now this will be the equation 1. Now we will see the vertical component. Okay, Now we can see this previous one was the vertical component. Now we can see the horizontal component. Now here we can, this will be, now acceleration is 0.2, so we can rearrange it like this, that t cos of 30 minus r is 122.4 minus t sine of 30 is equals to 12 into 0.2. 12 into 0.2. So this will be equals to 2.4. Okay. Now if we simplify it further, we can see t cos of 30 minus 122.4 plus t sine of 30 is equals to 2.4. Now if we simplify it, so this will be equals to what? Let's see the answer now. We can take it t as common, so this will be cos 30 minus sine 30 is equals to 2.4 plus 122.4. Now if we write it and if we calculate the final answer, we will get 2.4 plus 122.4 whole divided by cos 30 minus sine 30. So t will be equals to, let's see the answer. We can use the calculator. Okay. Now this will be 2.4 plus 122.4. You can verify the answer by yourself also, because sometimes we have to see that is there any calculation mistake or not, and if there is any calculation mistake, you can point out in the comment section. Now cos 30 minus sine 30, so the final answer will be 340.95. This will be the final answer. So the final answer will be 340.959. 340.959 Newton. So this will be the final answer, and if you have any doubt, you can ask it in the comment section. Let's move to the next one. Question number 6. Let's move to question number 6. Now in question number 6, a particle moves in a straight line. Particle moves in a straight line. It starts from rest at time 0 and accelerates at 0.6 t for 4 seconds. So it means that the equation for acceleration is given to us and accelerates at 0.6 t meter. So acceleration is, for the first 4 seconds, the acceleration is 0.6 t. The particle then travels at v meters for 11 seconds and finally slows down with the constant deceleration, stopping after a further 5 seconds. Show that v is equals to 4.8. Now we need to find out the value of v. Now we know that v will be equals to, we know that when if we want to find out from displacement, for distance, if we want to find out the velocity, and then to acceleration, then we have to use differentiation. But from acceleration to velocity, we have to integrate. Now if we integrate it, and we know that this will be equals to 0 to 4 and 0.60, we have to the equation of acceleration dt. Now this will be, v will be equals to, if we integrate it, 0.6 t square divided by 2, and then what we have to do, we have to put just upper limit minus lower limit. Now upper limit minus lower limit will be 0.6 t square, upper limit will be 4 square divided by 2, minus lower limit is 0.6 into 0 square divided by 2. This will be 0, and now we need to calculate it. So this will be fraction 0.6 multiplied by 4 square divided by 2. So this will be equals to 4.8. So velocity will be equals to 4.8 meters per second. So this will be the final answer. Let's move to the B part. Now for B part, we need to understand that for the first, we have to find out this velocity time graph. Now how we can create the velocity time graph? We just need, initially this graph will be given to you, and we can see this will be the graph, let's say velocity time graph. Now we need to calculate for the first 4 seconds. For the first 4 seconds, the velocity is fixed. So this should be the velocity for the first 4 seconds as given in the question. Now this will be velocity in meters per second, and this side will be the time in seconds. Now from till 0 to 4, the velocity will be 4.8, and then they are saying that after the particle travels at v meters per second for 11 seconds. Okay, for 11 seconds, so it means that from 4 to 15 seconds, because from 4 to 15 seconds the velocity will be same, and then they are saying that, and finally slow down with the constant deceleration, stopping after a further 5 seconds. Further 5 seconds means, okay, now we can see this will be the velocity time graph, and this point will be 15 and this point will be 20. I think that is it for this one. Let's move to the next one. Question number, the next part, that will be part C. Find an expression in terms of t for the velocity of the particle for 15 to 20 seconds. For 15 to 20 seconds. Okay, we need to find out the equation for the velocity. Now we know that in the last, from 15 to 20 seconds, the initial velocity is 4.8. Let me write it over here that initial velocity u will be 4.8, and then we have the final velocity will be 0. Then we have time is 5 seconds, and we need to find out the acceleration. We don't know about the acceleration. Now, how we can find the acceleration? We can use the initial the equation of motions. So this will be u v is equals to u plus at. Now we can use this one to find out the acceleration. So v is 0, u is 4.8, plus we don't know about the a and t. So acceleration will be equals to minus 4.8 divided by time is 5 divided by 5. So acceleration will be equals to fraction minus 4.8 divided by 5. So this will be minus 0.96 meters per second square. Okay, now this one is the acceleration for the last of the particle for 15 to 20. So now what we can do is we need to find out the velocity. So we know that velocity will be equals to, this should be equals to, v will be equals to 4.8 minus 80. 4.8 into the acceleration was minus 0.96. Basically we need to add it, so minus 0.96 into t. So t will be, let's see the t will be t minus 15 because we need to subtract it. So this will be the expression for the duration of 15 to t 20. The second way is there is another way to solve for solving this question. That is the mathematical approach. We need to find out the equation for the last portion. For equation of a straight line, what we have to do is we need to find out, we know that this point is 15 and 4.8. We know the gradient, the acceleration or the gradient is the gradient will be, how we can find out the gradient? So gradient will be y2 minus y1, 4.8 minus 0 divided by x2 minus x1. So 20 minus 15. So this will be equals to, gradient will be equals to 4.8 divided by 4.8 divided by 5. So the slope will be, as it is going downwards, so slope will be minus 0.96. Now we can use the y minus y1 is equals to m into x minus x1. So this will be equals to y minus 4.8 is equals to m is minus 0.96 into x is x minus x1. x1 is 15. Now basically here the x is t and that y is b. So we can write it as v is equals to 4.8 minus 0.96 into t minus 15. So we can see that the expression will be same from the both ways. We can use the equation and we can use this way. I think this one is the better way to find out the equation or the expression for any straight line. Let's move to the D part. D part is total distance. We need to find out total distance traveled by the particle. How we can find out the total distance traveled by the particle? For total distance, we know that velocity time graph is given to us. So we need to find out the total distance. So how we can find out the total distance? There are two ways to find out the total distance. The first one is the area under the graph, and the second one is the integration. Now, if we use the area under the, if we try to find out the area under the graph, so we know that for the first part, the total distance will be equals to area of the triangle 1 plus area of the rectangle. Second portion is the rectangle, and the last one will be area of the triangle 2. Okay, now let's find out the area of the first triangle. 1 by 2 base into height. Base is 4 and the height was 4.8. Similarly, for area of the rectangle, we know that this length is 11, this length is 11, and this length is 4.8. So 11 into 4.8, length into width, 11 into 4.8 plus area of the triangle 2. Now this length, base is 5 and height is 4.8. Base is 5, 1 by 2, base into height. Now if we simplify it, we can get the final answer, and for final answer we can simplify it like this. This will be 2, and 2 into 4.8, let me simplify it over here. 2 multiplied by 4.8 plus 11 multiplied by 4.8 plus fraction 1 by 2 multiplied by 5 multiplied by 4.8. So this will be equals to 74.4. So the total distance will be 74.4. 5 multiplied by 4.8, this one is right. 4.8 into 11 and then 2 into 4.8. This will be equals to 74.4 meters. So the distance will be equal to 74.4 meters. This will be the final answer. Let's move to the next question. Question number 7. This will be the last one, I think. The two particles A and B of mass is this respectively. A and B of mass is 3 kg and 5 kg respectively are connected by light and extensible string that passes over a fixed smooth pulley. The particles are held with the string taut. It means, now this is a very important word, it means that there is a tension, and we know that the direction of the tension will always be away from the point of observation. So this will be the tension, and this will also be the same tension, and its direction will be away from the point of observation, and weight is acting downward. Now here the weight is acting downward, which will be 30, weight will be equals to 30 kg. And for this one, weight will be acting downward, and it will be weight will be equals to 50 kg. Now we know that they're saying that the particle held with the string and taut and straight parts vertically. Particle A is 1 meter above a horizontal plane, and particle B is 2 meters above the plane. If these particles are released from rest in the subsequent motion, A does not reach the pulley, and after B reaches the plane, it remains in constant with the plane. Find the tension in the string and the time taken for B to reach the plane. Okay. Now it means that the acceleration for particle A will be in the upward direction, and the acceleration for particle B will be in the downward direction. Now we just need to separately look at the particles. Like the first particle will be, let's say the particle A. For particle A, we need to create the equations. F is equals to ma. Now F is equals to ma. The forces will be T is going up, mm, T is going upward, T is going upward, and weight is going downward. So we can write it as T minus 30 is equals to ma. M will be 3 and A, 3a. Similarly, for particle B, we will have two forces. T is going upward, so T minus 50 is equal to, as acceleration is going downward, so I will take it in a negative way. So minus what? Minus ma. M is 5, so minus 5a. Now we can simplify it like this, that T is equals to 3a plus 30, and from here T will be equals to 50 minus 5a. Now we can solve it simultaneously, equation 1 and equation 2. So we can get it as 3a plus 30 is equals to 50 minus 5a. So this will be 8a is equals to 50 minus 30. So from here we can see 8a is equals to 20 and a will be equals to 20 by 8, which means that acceleration will be equals to 20 divided by 8. So this will be equals to 2.5 meters per second square. This will be the answer for the acceleration. Now find the tension in the string. Now we can find the tension in the string. How we can find out the tension in the string? Now we know that initial velocity is 0. Let's see the data and the distance. Let's see the distance. Distance is 2 meters. Yes, distance is 2 meters because it's saying that when it reaches the plane B. So distance is 2. So let me write that distance is 2 meters, and then we have acceleration. But before this, we know the value of a, so we can easily find out the value of t. So the t will be equals to 3a. A is 2.5 plus 30. So the tension will be 3 into 2.5, 3 into 2.5 plus 30. So the tension will be 37.5 Newton. This will be the final answer for the tension. Now let's find out the time. So acceleration is 2.5. We know the acceleration as well. Acceleration is 2.5. And then we don't know the value of t. Okay, now what we have to do, we can use equation of motion. So S is equal to ut plus half at square, ut plus half at square. We know the distance, it's 2. We know the initial velocity, it's 0 plus half at square, 2.5 into t square. Now if we rearrange it, we can easily find out the value of t. Now this will be 2 is equals to 1 by 2 into 2.5 into t square, and if we rearrange it, 4 is equals to 2.5 t square. So 4 divided by 2.5 is equals to t square. So t will be equals to 4 by 2.5. Now this will be equals to fraction 4 divided by 2.5. So this will be equals to 1.26. So 1.26 seconds. Yes. So time will be equals to 1.26 seconds. This will be the final answer. I hope that the concept is clear. Let's move to the B part, the last part. Find the time for which A is at least 3.25 meters above the plane. Okay, this line is very important, that at least 3.25 meters above the plane, particle A. Okay, now first of all we need to find out the we need to find out the time, but we know that we have to see the given data, that initial velocity is 0 and acceleration will be same as for the particle B. This acceleration will be same. Now acceleration is 2.5, so we can say that acceleration will be 2.5 and the distance will be 2 meters, because the distance the particle A will cover the distance 2 meters. So we can use the equation to find out the velocity, the final velocity. This will be v square is equals to u square plus 2as, u square plus 2as. So v, basically this is one is the velocity of the velocity of the particle A. So v square will be equals to 0 square plus 2 into 2.5 into 2. So if we simplify it, v will be equals to 4 into 2.5 will be 10. So 10, v square is equals to 10, which means v is equals to square root of 10. This will be the answer. This will be the velocity of the particle A. Now we can use it to find out the final. Now this one is the initial velocity after the after 1 meter, after covering the distance of 1 meter. Now because we know that till here, let's say the particle is now it has been reached from this point. This one is the distance of 1 meters. Now the particle has reached up to this point, the distance of 2 meters. Now after, basically the total length is 3 meters and we have to reach out 3.25. Now we need to calculate the time, the velocity between these two. Now how we can calculate? We know that this distance is 0.25 meters, and for this phase the initial velocity will be square root of 10 and the acceleration will be, because the particle B is now not moving, it is at this place, this one, it is at rest. Now it is moving just because of the gravity, against the gravity. So that is why A will be equals to minus g. And then what will be the value of final velocity? We don't know. So we can use it again, we can use the equation of motion again, and this will be v square will be equals to u square plus 2as. V will be equals to u is square root of 10 square plus 2, a is minus 10 and distance is 0.25. This will be equals to v will be equals to 10 minus 2 into 10 20 into 0.25 whole square root. So v will be equals to let me calculate, 10 minus 20 into 0.25. This will be equals to 5. So it means that this will be equals to square root of 5 meters per second. Now again we have to see that because of the gravity it will move further in the upward direction. So that time duration will be u is equals to now square root of 5 and then final velocity till it stops. So final velocity will be 0, acceleration will be minus g, and we have to find out the time. Now the time will be v is equals to u plus at. So v will be 0, u will be square root of 5 and at minus g into t, which means that this will be 10t is equals to square root of 5. So t will be equal to square root of 5 by 10. So if we calculate it, fraction square root of 5 divided by 10. So this will be equals to 0. Time will be 0.2236. Square root of 5 by 10 will be 0.223 seconds. So time will be equal to 0.223 seconds. Now we need to find out the overall time. They are saying that at least find a time apart for which a is at least 3.25. So we know that from, let's say, from this distance, which is 3 meters above the ground, till this distance, this time duration is 0.223. So we know that it has to come back. It has to come back here. So at least means that greater than 0.25. So what we have to do, we have to multiply it with 2. So if we multiply it with 2, because the return time is also included, so this will be equals to 0.4471. So time will be equals to the total time will be equals to 0.44721 seconds. This will be the final answer. So that is it for today. Today we have discussed question 5, question 6 and question 7 of October-November 2024 paper 43. If you have any question, you can ask it in the comment section. Thank you.